But so this was a pop quiz which was related to the motion. As you can see, a man dives from a platform into a swimming pool, which is 12 meters above the water surface. The graph shows a vertical displacement. So vertical displacement, as you can see here, the graph for a vertical displacement is starting from a maximum value. So what is the origin in this question? So this is a graph for the vertical displacement. What? Because the vertical displacement is 12 here, and the vertical displacement is maximum in the beginning. If a platform or a diving board was the platform, if this was the origin, then this displacement should be 0 and then it should increase. So the origin in this case is considered as this point as origin. So means what will happen, as you can see, when a diver jumps, if he's at this point, the vertical displacement is decreasing. When he's at this second point, say he's at this point, the vertical displacement is getting. When he just reached the water surface, the vertical displacement will be 0. But then what happened? He does not stop at the water surface, he will go inside. So when he is going inside, now when you are measuring a displacement, you can see the displacement is downward now. So that's why, like if this was plus 12, plus 8, 0, and then this will be negative 4. So that's why the graph, you can clearly see from the graph that the displacement was positive and then it is negative. So why the displacement is negative? Like as he's coming down, his displacement was decreasing, and then when he's inside going inside the water, underwater, his displacement is negative because we are calculating below the origin or in opposite direction. That is the graph for displacement time. Then state how the graph shows that the man initial vertical velocity is 0. So how it shows an initial vertical velocity is 0. The displacement time graph, the slope or the gradient represent, because the gradient is 0. At this beginning, the gradient is 0. It's a horizontal. This section, the gradient is 0. It means the vertical velocity is 0. The slope is 0, or the gradient is 0. So the vertical velocity is 0. Determine the vertical velocity as he entered the water. So this is the point. This is the point where he entered the water. So we need the velocity for this section. So we can take this section until it is a straight line and take 2 points. The first point on x-axis, that will be x1. The first point on y-axis, that will be y1. This point will be x2 and this will be y2. Just work out the gradient y2 minus y1 over x2 minus x1. And that will give us the velocity at which he enters the water surface. Is it clear? How to work out? You just have to use a value here. If there is no loss of energy, yes, you can use. Why didn't you take the gradient under? So why we are taking the gradient in this part or the section here? See, this is a point where he hits the water surface. So I need the gradient of this region. Because as you can see here, only thing what happened, the velocity does not change. Only the direction has changed, but the gradient does not change. This is this part. So instead of taking only for this section, I include a greater region so that I'll get a more accurate result. because greater the difference between the 2 points, more accurate result you get. So only what I have to do, like this is the point where he hits the water surface. So I have to take a gradient of this section. So only if I take for this part, I can continue downward as it is a straight line. So I can continue downward. Or you can also use this section. You will get the same result. It won't make difference. So I can use like 2 points. I can take this as x1. The relative point will be y1. Then this will be x2 and the relative point will be y2. And using a formula, y2 minus y1 over x2 minus x1, y2 minus y1 over x2 minus x1 will get the final answer. The next part, so this was the vertical velocity. Before entering the water, the man has a constant vertical acceleration. After entering the man has a constant vertical deceleration. So they already mentioned constant acceleration and deceleration, so it will be a straight line. We can use an equation, but the thing is, whenever a graph is given, they expect that you use a graph instead of using the formula for the energy or using the equation of the motion. And in the question, they did not mention anything about the acceleration being constant in the beginning. That's why you cannot use, like as one of the student is asking, can we use this equation 2as equal v square minus u square? The reason why it's not suitable here, because they did not mention acceleration is constant. Next part they mention it is constant, but not in the previous one. The next one, before entering the water, the man has a constant vertical velocity. After entering the water, man has a constant vertical acceleration and deceleration. Now, we have to sketch a graph. So first, at what velocity he is entering? When we work out the gradient of this section, what was the value of the gradient when we work out the gradient of this section? But he has a constant acceleration and then the constant deceleration is there. The gradient 13 or a 14 negative it will be. According to your value, you will work out 13, 14, some of them are 14 or 15, okay. So example, if I'm taking as 14, so this value was negative 14. So I want a velocity time graph for this motion. So for a displacement time graph, what velocity time graph represent? And what it is a negative velocity, like negative 14 is there. And what about the time intervals? When you use this graph, so what we'll do, yeah, we'll mark a point, but we have a negative velocity. Like here, when he jumps, he has a velocity of 0 meter per second vertical. Before he hits, he is having a velocity of negative 14 meters per second. And he is having a constant acceleration. And what point at what time he hits the water surface? When it was 1.5 seconds. So first what I have to do, from 0, this is 1.5 and 14, this will be like 10 boxes equals to 10. So each is representing 1. So 14, example, this is 14 here, a negative 14. So we mark a point negative 14. And because they mention he is having a constant acceleration, So if he's having a constant acceleration, so we'll draw a graph like this. Is it clear, the first section of the graph? Anyone having a doubt? The first part of the graph. Now the second part, what will happen? This was the first part of the graph. Now the second part, at what time he completely, because you can see the displacement is there and then it become horizontal, means the velocity will become zero here, as again at this point the slope is zero. So when time is 2.1 means he stopped. So when time is 2.1, he stopped completely. So we'll draw, and he's having a constant deceleration and accelerations. So it should be a straight line. So this will be the velocity time graph for this diver, which reached the water surface when time was 1.5 and he stopped when time is 2.1. Is it clear, this question about completing a graph?